Hi guys, my name is Monby and I'm a high school student from California. Today we're going to be covering a basic algebra topic. This topic is really essential to understanding algebra, and as you learn more math, understanding those more complex types of math. So we're going to be covering the basics of how to solve equations. So by the end of this video, you're going to learn how to solve basic algebraic equations using a variety of different strategies that we're going to go over today. So let's get started. But before we do, we need to keep two rules in mind when we solve equations. So rule number one is that if you change both sides of the equation by the same amount, the equality is still true. And rule number two is that you need to isolate the variable to solve. So what rule number one basically means is that, say, if you add the same number to both sides of the equation, or if you divide both sides of the equation by the same number, the equation is still going to be true. And what number two means is that you need to make sure that on one side of the equation, the only thing left is the variable or the letter, and on another side of the equation, everything else is there. So that includes basically any kinds of numbers. So now that we've gone over those basics, we can start looking at our very first example problem. And the very first type of examples that we're going to be covering are all one-step equations. So this means that these problems all just require one step to solve. So they're pretty straightforward, but again, they're super important so that you can understand this stuff later on. So let's get started. Our first example is x minus 10 equals 4. All right, so our variable here is x, and we need to remember that a variable, even though it shows up as a letter, really just represents a value or a number. So we see x minus 10 equals 4, and the first thing we need to remember is that we need to isolate the variable. So we need to make sure that on one side of the equation, the only thing left is the x, and on the other side of the equation, we're just left with the numbers. So in order to isolate, we can use rule number one, which is that we can add the same number to both sides and still preserve the equality. So the way we're going to isolate this x in this equation is by adding 10 to both sides of the equation. All right, so once we do that, we have on the left-hand side x minus 10 plus 10, and on the right-hand side, we have 4 plus 10. So once we solve that out, we get just x on the left side, and on the right side, we have 14. Now, since x is the only thing on one side of the equation and there's just a single number on the other side, that means that we've solved the equation. So in this, x represents the number 14. Now, even though we've done all the math, we need to make sure that we've actually done it correctly. So we're going to check our work. In order to check our work, all we need to do is plug in 14 for x in the original equation and make sure that the equation is still true. So when we go back to check, we see 14 minus 10 is equal to 4. And that's a true statement. So that means that we've solved our equation correctly. All right, so for the next example, you can try solving this on your own. There's decimals, so it may look slightly more challenging, but it's the same level of complexity, and you can use the previous example as a guide. So go ahead, get a pencil and a piece of paper, and start solving this problem on your own. Just pause the video and take your time. So I'll give you some time to solve the equation right now. All right, so I'm assuming that you tried to solve it on your own, and now we're going to go over the problem together. So what we have here is 0.7 equals y plus 0.4. So just like we did before, we need to isolate the variable. And the way we do that is that we can subtract 0.4 from both sides. So if that's your very first step, good job. You did the right step. And once we do that, on the left side, we're left with 0.7 minus 0.4, which leaves us with 0.3. And on the right-hand side, we're left with just y. So that means that we've solved the equation. So if you got 0.3 equals y, good job. If you didn't get this answer, don't worry. You're still getting used to this type of problem, and you'll get it as you practice more. So just remember, we're not quite done yet. You have to check our work. So when we plug in 0.3 for y in our equation, we get 0.7 equals 0.3 plus 0.4. And As you can see, that's a true statement, so that means that we've solved our equation correctly. So far, the examples that we've looked at just require addition and subtraction to isolate the variables, but the next couple will require multiplication and division. So our very first example is 13 equals negative 2m. And when you have a variable and a constant, which is what we call numbers, right next to each other in an equation, that just means that those two are being multiplied by each other. So this could also be read as 13 equals negative 2 times m. So again, we need to make sure to isolate the variable just like we went over in rule number 2. So in order to do that, we're going to divide both sides of the equation by negative 2. This will make sure that the only thing left on the right side is m. And once we do that, we get on the left side 13 divided by negative 2, which is 6.5 or 6.5. And on the right side, we're left with just m. That means that we've solved our equation, and m is equal to negative 6.5. So again, we need to remember that we have to check our work. And once we do that, we can see that 13 is equal to negative 2 times negative 6.5. All right, so again, now you can try the next example on your own. For this one, we have negative 4 equals k divided by negative 5. So go ahead and just on the same piece of paper, just solve it using the previous example as a guide, and don't worry if you don't get it on your first try. All right, so I'm assuming that you tried this problem on your own. So let's go over it. So we have negative 4 equals k divided by negative 5. So we have to isolate the variable, which is k, and in order to do that, we can multiply both sides of the equation by negative 5. So if that was your first step, good job, you're on the right track. Now what we're going to do is we have to make sure to actually work out that math. So we do negative 4 times negative 5 on the left-hand side, and then on the right-hand side, we're going to be left with just k. So that means 20 is equal to k. So if you got that, good job. If you didn't, don't worry, you'll get there with more practice. All right, but remember, we're not done quite yet. We have to make sure to check our work. So when we go to check our work, we plug in 20, where it says k in the original equation, and what we get is negative 4 is equal to negative 20 divided by 5, and that's a true statement, so that means that we solved the equation correctly. All right, so the next type of equation that we're going to try and solve are equations that require two steps to solve. So these might look more complex than the problems that we're used to from the previous few examples. Don't worry, they just build off of the same concepts that we've been talking about over these past few examples. And after you practice for a while, I'm sure you guys will get comfortable with it. So let's start with our first example. So over here, we have integer coefficients on the variables, which basically means that what's happening is that the variable, which is x in this example, is being multiplied by a whole number. When we have non-integer coefficients, that means that we're multiplying the variable by a fraction, or essentially just dividing it. So this equation says that 10 equals 6 minus 2x. So the first thing that we have to do is make sure that the negative 2x is on its own, so it's isolated. And in order to do that, we can subtract 6 from both sides of our equation. Once we do that, we're left with 4 on one side of the equation, on the left side, and we're left with just the negative 2x on the other side. So now this equation should start looking familiar. It looks really similar to what we are used to in terms of the one-step equations. And so you should be able to figure out that our next step that we need to take is just dividing both sides of the equation by negative 2. So once we do that, on the left-hand side, we're going to be left with just negative 2, and on the right-hand side, we're going to be left with x. So our final answer for this problem would be x is equal to negative 2. So that's the strategy that we need to use to solve two-step problem. Just take it one step at a time and try to make the equation look like the one-step problems that we're more comfortable with. But remember, we're not done quite yet, so we need to check our work. And once we plug in -2 for x, we can see that it does work out to be a true statement, and you can try that on your own if you have some extra time. Now you can try this next problem on your own. Again, don't worry if you don't get it right on the first try, you'll get it with practice, but the problem that we're working with right now is 2x plus 5 equals 11. So go ahead and try that on your piece of paper. Just pause the video for a few seconds and give it a go. Okay, so I'm assuming that you had the chance to try this problem out for yourself, and now we can go over it together. So the first thing that we need to do is try to get it to look like a one-step equation. So in order to do that, we need to subtract 5 from both sides. And if that was the step that you took, good job, you're on the right track. So once we actually solve that out, we get 2x on the left-hand side, and then we get just 6 on the other side. And now this looks a lot like the one-step equations. So in order to solve, you should know that what we need to do next is just divide both sides by 2. So again, if you did that as your next step, good job. So once we've actually done that division, what you're going to be left with on the left side is just x, and on the right side 3. And because the x is isolated, that means that we've solved the equation. But remember, you're not done if you stopped here. You have to make sure that you check your work. And once you plug in 3 for x in the original equation, you just have to remember that when there's no space between a number and a variable, they're being multiplied. So once you've done that, you can check to make sure that that is true. And it is, so that means that we've solved the equation correctly. Alright, so now we're going to be moving on to our last few examples, which deal with non-integer coefficients, which just means that instead of being multiplied by a whole number, the variable is being divided by a whole number. Alright, so over here we have a variable as q, and the equation that we're working with is q divided by 15 minus 1/5 equals 3/5. So don't let the fractions intimidate you. We can just take this one step at a time, just like we did with the last one. Alright, so the very first thing that we need to do here is that we can add 1/5 to both sides of the equation in order to get this problem to look a lot like the one-step problems that we're used to. So we add 1/5 to both sides, and once we have done that, we get just q divided by 15 on the left-hand side, and on the right-hand side, we're left with 1/5, or 4/5, sorry. And now we can start to solve it like a one-step equation. So in order to do that, we can multiply both sides of this equation by 15, because you need to remember a fraction is just like division. So we can multiply both sides of this equation by 15, and what we're going to be left with on the left side is just q. And on the right side, to solve it out, you're going to have to do a little bit more calculating, but you'll be left with just 12. So that means that our final answer is that q is equal to 12. And again, just check your work. So we'll have, plugging in 12 for q, we'll have 12 divided by 15 minus 1/5 equals 9/15. And once you simplify that, you get 3/5. That means that we've done our work correctly. Alright, so for this example, again, just try it on your own. We have j over 4 plus 2 equals 9. So just use the same strategy that we've been using for these past few examples. Try to get the equation to look like a one-step equation, and then take it from there. And remember to keep your 2 rules in mind. So go ahead, pause it, and try it on your own, and we'll come back together in a few seconds. Alright, so I'm assuming that you tried this example, so now we'll walk through it together. So what we need to do is we need to make this look like a one-step equation. And in order to do that, the first step that you should have taken is to subtract 2 from both sides. So if you did that, good job, you're on the right track. Now, what we need to do is actually solve that out. So once you did that, you're going to be left with j divided by 4 is equal to 7. So now we've gotten it looking like a one-step problem. And in order to isolate j, what we can do is multiply both sides of the equation by 4, which should have been your next step. And once you solve that all out, you should have gotten that j equals 28. If you got that far and stopped there, remember you still have one more step to go. So you need to check your work, and once you plug in 28 for j in the original equation and calculate it out, you should get that the equation holds true and that we've solved the problems correctly. So thank you for watching. I hope that this was helpful. If it's not, you can feel free to contact me using the information over here on this slide. I hope this was helpful and gave you a really good introduction to algebra, and I hope that you guys have a great day.